In example 4, we're going to use the rational zero theorem to find the rational zeros of each polynomial. The rational zeros theorem has us look at the constant term and the coefficient of the leading term and put them into fraction form. And this will give us all of the possible rational zeros of a polynomial. Rational numbers are things that look like fractions. So for the polynomial that we see here, the possible zeros, or the possible rational zeros, are going to be factors of 24, that's the constant term, divided by factors of 2, which is the leading coefficient. So this gives us quite a few options. This would be, I'm going to list all of the numbers that can factor into 24, and it can be either the plus or the minus version of them. So I'm just kind of going through numbers and thinking about what divides evenly into 24. There's a lot. Those are all the possible numbers in the numerator. The possible numbers in the denominator are 1 and 2. So our possible, these are not for sure. We know that we're going to have only at most 3 zeros because the leading term, or the degree, is 3. But this is all the possibilities. So the possible rational zeros are every single one of the numbers in the numerator divided by plus or minus 1. Those will all stay the same. So plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. And then if I take all of the numbers in the numerator and divide them by 2, I'll also add plus or minus 1/2. 2 divided by 2 is 1, plus or minus 3/2. 4 over 2 is going to give me 2, which I already have. 6 over 2 would give me 3, which I already have. 4. All the rest of these are going to give me numbers that I already have. So this is a lot of options. So what we do next is we use the remainder theorem to try and test which of these values might actually be a 0, so that we can simplify this into something that's raised to the second power and kind of work our way down to find the other zeros. So let's it's always good to kind of just start with positive and minus 1 because they're usually the easiest to plug in. I'm going to start by plugging in 1 to the original. So I'll have, I'm plugging 1 in here. So that'll be 2 plus 7 minus 10 minus 24. Plug that into a calculator. It's not going to be 0. You can see that it's minus 25. So I'll try negative 1 next. That'll give me, let's see, negative 2 plus 7 plus 10 minus 24. I don't think that's going to be 0 either. I'm getting negative 9 there. All right, let's try some more numbers. Let's try 2. Let's see, 2 times 8, that'll be 16, plus 28 minus 20 minus 24. That looks promising. Yeah, that gives me 0. Okay, all I've got to do is find 1, because then I can use synthetic division to break this down into something smaller. So let's go over here to this side. 2 is a 0 that I found, and I'm going to divide it into my original. The coefficients there were 2, 7, negative 10, negative 24. Let's see, 22. This will be 12. Yeah, that works. 0 is my remainder. All right, so rewriting the original, I know that 2 was one of my factor, or 2 is a 0, so x minus 2 is a factor. And I just found that after doing synthetic division, I have 2x squared plus 11x plus 12 left over. And I think that can be factored. Let's see, x minus 2, and this will be a 2x, this will be x. Let's see, if I make that 4 plus 4, that'll give me 8, and plus 3, that'll give me 11. Yeah, that works. So I'm able to factor this completely. The zeros in this case are x is 2, x is, what is this? Negative 3 halves. That was one of the ones that we saw as a potential 0 here. And also negative 4. That was also one that we saw here as a possible 0. Let's look at a second example here. So what we do is we start by thinking about what are all the possible rational zeros. And it'll be factors of the last number, which in this case is 12, divided by factors of the first number, which in this case is 1. So this is going to give us less options than the last example. So plus or minus 1, 2, 3, 4, 6, and 12. Again, I'm just going through all of the whole numbers that divide evenly into 12. And for 1, it's just plus or minus 1. So all of these numbers here in the numerator are what we're going to try to test to see if they will give us a 0 remainder, meaning that the factor will divide evenly. So let's always start with 1 and negative 1 because they're the easiest to plug in. 1 minus 2 minus 7 plus 8 plus 12. When you plug 1 into a polynomial like this, you really just are taking the coefficients that are in front of the variables, because 1 raised to any power is just equal to 1. So I'm going to have, I don't think this is going to be 0. I'm getting 12. Let's try negative 1. I'll have 1. That'll be negative. So plus 2 minus 7. When you plug negative 1 in, anything that has an even power will stay the same. Anything that has an odd number is going to switch to be the opposite sign. So this next one is going to be a minus 8 and then plus 12. Let's see, 3. Oh yeah, this gives us 0. Okay, so negative 1 is one of the zeros. So then we'll use that to do synthetic division. So let's do this over here. We're going to use negative 1, and we're going to go back to our original and grab the coefficients, which were 1, negative 2, negative 7, 8, 12. Uh, 3, negative 4, negative 12. Yeah, that works. All right, so rewriting our original now, our equation is now, our polynomial is now x plus 1. That gave us negative 1 as one of the zeros. And then this has now been broken down something to the third power. So x cubed minus 3x squared minus 4x plus 12. And now what we'll do is we'll start the process over again, thinking about the possible rational zeros. And if you look at the numbers here, this last number and this first number, it's actually going to be the same rational zeros that we had before. So I'm not going to test 1 again because I tested it the first time and it didn't work. So I want to try to find another 0 here. So I'm going to move on to 2. Let's see if 2 works. So I've got this new polynomial here. Let's call this guy g of x. And I want to know what g of 2 is equal to. And again, I'm now working with this this polynomial, not the original anymore. When I plug 2 in here, I'll get 8 minus 12 minus 8 plus 12. Yeah, that equals 0. So now I can repeat the process of synthetic division. I'm going to put 2 as my 0, and then my coefficients are 1, negative 3, negative 4, and 12. So 1, 2, negative 1, negative 6. Okay, so thinking about my original, going back to this guy here. So f of x is now x plus 1, that's what we found from the first one, and now we have x minus 2 as a new factor. And then here we had what, x squared minus x minus 6, and that factors into x minus 3, x plus 2. So in this case, we're able to find 4 zeros. That's the most that we would expect because our original polynomial was raised to the 4th power. So this is a way for us to find the zeros and then also to think about what the graph is going to look like. All right, I've got one more example here. In this example, we don't have a lot of options. The possible rational zeros are factors of 1, that's the constant term, and then also factors of 1, that's the leading coefficient. So we've only got plus or minus 1 as options. Let's plug in positive 1 and see what we get. 1 minus 5 plus 2 plus 1, which is negative 1. And let's plug in negative 1 and see what we get. Negative 1 minus 5 minus 2 plus 1, which is negative 7. Neither of these is giving us 0. So that means that we don't have any rational zeros. It means that they're all going to be some decimal numbers. So what I want to do is let's switch to the graph in Desmos to see what this looks like. So here's the function that we were just looking at, and you can see that that's one of our zeros, that's one of our zeros, and that's one of our zeros. So we have to go to different methods to find the zeros in cases like that. The rational zeros function really works only if we have nice whole numbers, and it doesn't always work for all scenarios.